All right, so we're just going to finish up talking about what we talked about in class on Monday. So on Monday we talked a little bit about sum of 2.5, which is algebraic limits. Okay, and so we did a few very basic ones. I want to hit a few of those just to remind ourselves. So if you had this cat here. Yeah, that guy. Take the limit as x approaches 2. Okay, what do you get? Well, you got 4. So you get minus 10 plus 6 is 0 on top. And on the bottom, you get 4 minus 6 plus 2 is 0. You get 0 over 0. And again, if you have a polynomial over a polynomial, that is, you have yourself a rational function. Now, sometimes people will say, like, hey, sine over x squared plus 5 is also a rational function. Technically, that's not true. Technically, because it's, that's what I'm looking for. Come on, Jay, you got this. Because it's not a polynomial over a polynomial. However, okay, that some people still call it that. So, but if you have a polynomial over a polynomial, a true rational, if you see this, first of all, 100% of the time, it's a whole. That means it's a removable discontinuity, which means that you can factor this pig. And I 100% promise you that there's an x minus 2 on the top and the bottom. How do I know that? Well, because what value of x makes it 0? 2. And so 2 minus 2 is 0. 100%. Well, that means this one's this, and this one's this. That's right. That's right. That's right. Now, could I dink around it? Well, is it x minus 6, x plus 1? First of all, no. It doesn't factor that way. Second of all, 2 does not make that 0. Am I right? Am I right? Yes, I'm right. Of course I'm right. So therefore, that cannot be the case, yes? So because you know 2 is a 0 and a 0, it has to be that and that. And so we say that these guys have the same limit. We do not say they are equal. They are not equal. In fact, they are equal everywhere except positive 2 rather. So if you plug 2 into this cat, you get negative 1 over 1, which is negative 1. Again, this guy here, x squared minus 5x plus 6 over x squared minus 3x, 2, does not equal x minus 3x minus 1. That is not true. That is not true. That is 100% not true. Now, if you went comma, x does not equal 2 on this fella, then they would be equal. Are you with me? In other words, if I restricted the domain of that guy, then everywhere else that we are gooch. But at 0, this fella's got a hole. This guy was good to go. Okay, now they're equal. Without that domain restriction, they are not equal. However, the limit as x approaches 2 of this cat and the limit of x approaches 2 of this fella does in fact equal the limit as x approaches 2 of this guy over this guy. Okay? Now remember, this guy is what? He is continuous at x equals 2, correct? And so, because he's continuous, I literally drop a 2 in. Bob's your uncle. All right? Piece of cake. Robert's your mother's brother, as the kids say. Okay? Yeah, nice. So, give me another one of these ones, Groom. Okay, well, the limit as x approaches 8 of, wait for it, what's going to be in the bottom, Groom? No. Yes. Nice. Now, Groom, is this technically a rational function? No. Does it give us 0 over 0? Yes. Is it theoretically then removable? Yes. Can I always do it? Well, sometimes. Now, anytime that you have a radical, x squared of x minus 4 minus 2, what we can do is we can multiply by the square root of x minus 4 plus 2. And if I do it on the top, I do it on the bottom. And of course, what is the cardinal rule of algebra? Whatever thou doest to the top, thou must, oh no, never mind. We just multiply by 1. That's all we're doing, dog. We just multiply by 1. On the top, we get x minus 4. Because when you take this times that, it's that squared, which is x minus 4. This is a difference of squares. This looks just like x plus 2x minus 2. True dat? Which you're going to get x squared, no x's in the middle, minus 4. In other words, it's a plus b, a minus b, and when you factor that or FOIL it out, you get a squared minus b squared, which means I'm going to get x squared. Yes, that's right. Yes, yeah. And then minus 4. Whoa. Over. Now, don't do anything with this crap. Leave it alone. For gosh sakes, just leave it alone. You're making your life harder, bud. Plus 2. Sorry, plus 2. So, what do I do here? Well, I don't need this parentheses. I just put it there just to show you. Wait a minute. That's x minus 8. But groom, there's an x minus 8 top and bottom. Correct. So you get this thing. Once again, the original problem and this are they the same? Let's find out. The limit as x approaches 8. Well, first of all, we'll back to it. Is the limit of the original, which is this guy, the same as the limit as this guy? And the answer, of course, is yes. Are they the same function? The answer is no. Why? Because this one I plug 8 in. 8 minus 4 is 4. Square root of 4 is 2. 2 plus 2 is 4. So the limit is 1/4. This fella is continuous. Well, honestly, he's continuous everywhere. This whole function is continuous everywhere now. But at least he's continuous at 8. Yes? This guy, discontinuity at 8. They are not the same function, but they have the same limit. That is a big deal. I cannot stress to you enough how much of a big deal. How much of a big deal that is. We have got to get this figured out. Okay, so you have to have that clear in your head. If you don't believe me, a feller just takes his desmos.com and he takes these parentheses, square x minus 4 parent minus 2 divide by x minus 8, and you get that thing. Nice. And you get the other fellow, which was 1 divided by squirt x minus 4 plus 2. OMGosh, they look the same. They are gooch everywhere except here. You see it is, in fact, a quarter. But on this guy, it's undefined. And so they are not the same function. But they are the same everywhere except at 8. Okay? Okay, that is a big deal. Okay, so when we do these, kind of keep that in the back of your head. Groom, do another one. Do another one. No? All right, fine. So I'm going to limit as x approaches 0 from the right. Now, what that tells me is that I'm probably going to have a radical or something like a radical function, something that only exists when x is greater than or equal to 0, or at least greater than 0, yes? And so I know that before I even begin, right? Like, why would you ask me this about this? The answer is 5, Kraken. The answer is literally 5, because this guy is continuous at 0, which means he's continuous from both sides of 0. So I would not ask you this question. And in fact, if you think about it, that's just obvious. 1 over the square root of x. Oh, Groom, it's like you know what you're talking about. Yeah, well, I know, bro. Minus 1 over, what was it? Oh, damn it. Square root of x squared plus x. Boy, yes, at 0, we are definitely screwed. Hey, what about 7? 7 works great. What about -5? Whoa, that ain't going to work, bro. That is not going to work. Okay, so this thing, the domain, of course, when you look at it, obviously bigger than 0. It has to be. Hence, the only reason I'm going to ask you a question, right? Groom, how are you going to solve this? Well, listen. Somehow I've got to clean this mess up a little bit. So, and after a while, you're like, bro, I have somehow got to get that square root x out of the basement. I don't know what to do with it. I'm going to leave that one alone for a minute. What do these guys have in common? I feel like they have one x in common. Now, bear with me for a moment. Are you with me? Are you still with me now? Are you with me? I hope you're with me. Ta-da! We just factored it out. Well, you can do that. Bro, I can do anything I want to do. Well, that's good. By the way, if you were ever concerned, is that right or not? Because if I graphed this thing and this thing, they better be what? They better be the same. So that if all of a sudden I get a weirdly, wildly different function, you're just like, that can't be right. Now, back in the day, as the kids would say, maybe we want to add these guys together. Yes, maybe we want a common denominator. So this one's going to be the square root of x plus 1 over square root of x plus 1 minus 1 over square root x. Square root x plus 1. And you're like, I don't know, Groom, that looks gross and disgusting. Well, yeah, I don't disagree. So then watch this. The limit as x approaches infinity from 0 from the positive side becomes this guy. You with me? Yeah, are you with me? Over this, right? I guess I don't really need the parentheses. I'll leave them there, I guess. That makes you happy. And you're like, Groom, you just made it messier. That will happen a lot of times when we're trying to make things happen. Okay, sometimes it will get grosser. That's a fact. But check it out, bro. That looks like right up here, a difference of squares again. Groom, should I multiply by the conjugate again? I would. And so on the top, I'm going to now have x plus 1 minus 1. Dude, this is so hot. Squared x plus 1. Nice. And the limit as x approaches 0 from the right. Well, now the top is just x. Can I simplify it? By God, I sure can. Yes? Because how many times does squared x go into x? It goes in squared x times. Right? Right? Squirt x plus 1. Now, what happens if you put 0 into here? Well, you get 0 on top, which we're gooch with, and over 1, which is just 0. Okay? That is a fact. That is what we wanted to do. Now, can I check myself? Well, I always can check myself. So it's 1 divided by squared x. Is it plus or minus? Can't remember. Minus 1 divided by squirt x squared minus, is it plus x or minus? Plus x, plus x, plus x. Oh! Hey, we're right. What do you know? Nice. Bro, the crowd goes wild. Wow. All right. So we're going to do some of those. We're going to have a little fun with them. Here's another one that's always a good time. Something like this cat. The limit as x approaches pi over 4. And it's going to be sine x minus cosine x over tan x minus 1. Hey, at pi over 4, that's squirt 2 over 2 minus squirt 2 over 2. And this is 1 minus 0 over 0. I mean, you're like, Groom, that's hopefully a removable discontinuity. Yes? And it should be. The question is, am I smart enough to make this work? Now, Groom, why did we do trig identities back in the day? Why did we do things that were just like seemingly difficult? For this very reason. Now, there's not much I can do with sine and cosine, but tangent, who is he? Tangent is sine over cosine. So I can write this as sine x minus cosine x over sine x cosine x minus 1. Yes? And then if I wanted to, which I do, I want that to be one number. So I need a common denominator. And for those of us that have done this a few times, you can start to see your way home from here. For some of you, you can't see it. You're like, it just looks grosser, Mr. Group. I don't like it. I don't like it. Which is, then, of course, the limit as x divided by over 4 sine x minus cosine x over sine x minus cosine x over cosine x. Now, some of you are like, can I do something with that? Obviously. But if you're not sure, this is like the whole number, so like 5, divided by a half. Yes, that's basically what we have here. So what do? We go 5 times 2 over 1, right? We invert and multiply. So for us, it's going to be the limit as x approaches pi over 4 sine x minus cosine x. I'm just going to go ahead and write over 1 times cosine x and sine x minus cosine x. And the answer is cosine x. So the limit as x approaches pi over 4 of the cosine of x, which of course this is continuous everywhere, but it's definitely continuous at pi over 4 is root 2 over 2. Piece of cake. I think we'll do one more here, and then maybe, I don't know, we'll see what happens on this one. So the limit as x approaches pi over 3, 2 cosine x squared, 2 cosine squared x minus, or plus 3 cosine x minus 2 over 2 cosine x minus 1. Now, Mr. Groom has a question. What is the cosine of pi over 3? It's a half. A half squared is a fourth. Plus 3 times the cosine, so it's going to be 3 times a half, so 3 halves, minus 2. So this, Mr. Groom, what are you doing, Mr. Groom? Cosine is a half squared is a quarter, so this is a half. Oh, there it is, right there. Duh. This is not 2 1/4, it's a half. And a half plus 3 halves is 2. 2 minus 2 is 0. Yay! On the bottom, it's a half times 2, which is 1. 1 minus 1 is 0. Oh, no. Maybe we can factor this. Now, hopefully I did this in class, but I don't remember because I haven't been in class yet. This looks an awful lot like 2x squared plus 3x minus 2 over 2x minus 1. I have a 0 and a 0. That means that I must have on top a 2x minus 1 times something over a 2x minus 1. Are you with me? That's what it looks like to me. And the other something must be an x minus, or an x plus, no, an x plus 2. That's going to be 4 minus 1 is 3x. Yay! And then this portion, as promised, will go away because that's the part that gave us the 0. So over here, you're like, Groom, are you just saying that this factors to cosine x minus 1 times cosine x plus 2 over... That's what I'm saying, bud. That's where the problem lies. Cosine of pi over 3 is a half. 2 1/2 would be our limit. And then, again, a guy can always come back and check himself. So remember, if you're doing cosine squared, you must do it this way. So it's cosine of x squared. Yes? And then plus 3x. No, damn it. Plus 3 cosine x. Okay, and then minus 2. Divide by 2 cosine x minus 1. Oh, dear. Oh, dear. Now, Groom, pi over 3. Pi over 3 is about 1, isn't it? Last I checked. So x equals pi divided by 3. Oh, dog. Oh, my. And what's happening here? Oh, dear. Oh, dear. Did I type something in funny? Oh, dear. Oh, my. Oh, say. Oh, say, can you see by the dawn's early light? Well, that clearly is not removable. Interesting. Interesting. Cosine squared x plus 3 cosine x. Is that what I put? Oh, it's 2 cosine squared. You big buffoon. You buffoon? Oh, snap. Right? Now, Groom, you said it was a removable discontinuity. Were you lying to us? No, I typed the problem in wrong. You watched me, stupid. Now, what you saw a minute ago was an asymptote. An asymptote is what? What's not removable. Okay? So what would have happened at pi over 3? You would have had an asymptote. You would have had a left-hand limit of negative infinity, a right-hand limit of positive infinity. The limit would not have existed. But here, my friends, here, oh, look what it's approaching, dog. As we get closer and closer and closer, it sure looks like it's getting awfully close to 2.5, yes? Nice. But if I'm on the purple line, look what happens. Well, no, not the purple line. If I'm on the green line, dadgummit. So right in there somewhere, it becomes undefined. Now, because it's pi over 3, it's not going to show up very well. Just know that. It's not going to show up very well because it is pi over 3. Pi over 3 is kind of a goofy number. So cosine of x plus 2. By the way, does that look like cosine of x? Sure does. Plus 2. Anyway, and you can see that they do, in fact, cross at 2.5. Okay? Because that guy is continuous. Well, he's continuous everywhere, but he's sure as heck continuous at pi over 3. All right, this was just a tie-in from the other day, or from yesterday. Do I want to do one more? Gosh, I do. I want to do one more. And I don't care if you like it. It doesn't matter to me. Okay, Parker? I don't care. So here's this one. The limit as x approaches 2 of x cubed minus 8 over x minus 2. Groom, that's 8 minus 8. That's 0 over 0. Oh, geez. You promised me this thing factors. I did, didn't I? Or did you lie to me? I didn't lie to you. I just got to figure out what it is. Groom, I am not as old as you. So I was not made to learn how to do how to factor a perfect cube trinomial, or the difference of cubes, rather. I was never made to learn that like you were in 19, I don't want to talk about it. Yeah, you're right. I hated it then, too. I didn't know I was going to become a math teacher, so, whatever. God has interesting plans for me. So, there it is. But how can I find this thing? Well, that's a great question. Let's do a little long division. Now, if you are a synthetic division person, you can also use synthetic division for this. Mr. Groom has never understood synthetic division very well. So I just do long division. How many times is x going to x cubed? It goes in x squared times x cubed minus 2x squared. After you do that, you subtract. So you get 2x squared plus 0x. How many times is x going to 2x squared? It goes in 2x times. That's 2x squared minus 4x minus. That's 4x minus 8. How many times is x minus 2? Or how many times is x going to 4x? It goes in 4 times. And that's 4x minus 8. And when you subtract, you get 0. That means that this guy times that guy is the same, yes? So we take the limit as x approaches 2. And if you evaluate, you get 4 plus 4 plus 4 is 12. Okay? So that's kind of neat. That's kind of neato, Groom. That's kind of just, it's fun. Now, again, most of these, over time, you start to see like, oh, it's the same stupid thing all the time. It is. So it's not terribly difficult, all right? And that's kind of where I want to leave off. Again, just tidying a few things up, giving you some more examples, okay? The problem with these things is a lot of you, anyway, have not seen enough of this stuff to be comfortable when you come to factoring. So that's kind of the point of this.